This is a note-taking guide for Math for Life, and this is day 8 of the probability unit. So today we're going to talk about some different permutations and combinations. We've been doing those already early in this unit, but today we're going to talk about how it works applied to using words to find permutations, and then how to do some compound combinations in just a minute. All right, so this first problem right here says find the number of unique permutations of the letters in each word. Well, really what it's asking is how many ways can I rearrange the letters in the word math to form different unique words. So really what I'm going to look right here is I can tell from looking at the word math that I have 4 different letters in the word, which means in my first position on my word I would have 4 letters to choose from. But after I use that first letter, I only actually have 3 letters left to choose from. Then I would have 2 letters to choose from. And then very last of all, I would only have 1 letter left to choose from. So if you remember when we talked about what this symbol means right here, this exclamation point, it's actually called a factorial in math. And we learned that a factorial meant that if I had a number like the number 4 and I did 4 times 3 times 2 times 1, I could actually write that as 4 factorial, meaning start with the number 4 and times it by every number lower than that all the way down to 1. So on my calculator I could do 4 times 3 times 2 times 1, or I could punch in the 4 factorial. The factorial is found underneath the probability on the key on the calculator. So you have a key on your calculator that says PRB. If you hit that, underneath that, you have 3 different options. So your options on that would be number 1 is the NPR, which is the the permutation key. On number 2 you have NCR, which is the combination key, and then number 3 is that exclamation point, which is the factorial key. So if you do 4 and then hit the probability key and then put the number 3 in to get that exclamation point, it will give you your solution, and your solution will be the number 24. So I can rearrange the words or the letters in the word math 24 different unique ways to get 24 different words. Probably not English correct words, but just different ways to rearrange those words. Okay, let's go on to the next one here. I have the word further. So the very first thing I'm going to do is I'm going to count these letters in the word further and see how many there are. So when I count those, I get 7 letters. So I'm going to go with 7 factorial. But here on this particular word, I have a problem, because if you notice right here, I have the letter R right here, and I have the letter R right here, meaning that letter repeats itself. Now, if I'm going to write permutation for this of how many unique ways I can write the letters on this word, I would have a problem there, because when I write the letter R, is it this letter R or is it that letter R? Which means it's not necessarily unique at those positions. So what I'm going to do is I'm going to divide this factorial by my repeating letters. So that letter R repeats 2 times. So I'm going to divide by 2 factorial to keep this so that they're unique. I don't have any other letters in this word that repeat, so I actually can just punch this in my calculator, again using that factorial key that's found underneath that probability key in our calculator. And when I punch this in, I have 2,520 different ways I can rearrange the word further to get unique permutations of that word. All right, let's try another one and see how we can do. The next one is the word Mississippi. So again, I'm going to count how many letters are in the word Mississippi, and if you count those, you end up with 11. There's 11 different words or letters in the word Mississippi. So I'm going to start out with 11 factorial, but then again I have to divide by every single repeating letter and how many times it repeats. So I'm going to start with the obvious ones here and do the S's. So there's 1 S, 2 S, 3 S, 4 S's. So I have to divide this by 4 factorial. Then I'm going to go and do my P's. So 1P, 2P. So I'm going to have a 2 factorial. And then I have some I's that repeat. So 1, 2, 3, 4 i's, which is another 4 factorial. So really on this unique permutations of this word, I have a lot of numbers on the bottom that are going to not be able to be repeated because they won't be unique. So I'm going to punch this on my calculator. I can actually use the fraction key on my calculator and punch this in just as it is, how it appears right here on this, and then just hit equals on my calculator. And when I do that, it will tell me how many different ways I can rearrange this word in unique permutations, and the answer for that will be 34,650 different ways. All right, let's try one more, see how we're doing. This is a short word, it's hello. There are 5 letters in the word hello, and the only part that repeats are those L's right there. It's repeating 2 times, so I'm going to divide by 2 factorial. And my answer there is the number 60 when I punch that in my calculator. All right, what I want to do now is I want to give you just a second. I'm just going to sit here and be quiet for a minute. I want to try to let you do the next 2 words on your own. The next 2 are yesterday and then 17. So take just a minute and try that on your own. And while you're doing that, I am gonna get ready with my answer. All right, when we count the letters in the word yesterday, I believe there's 9 letters there, so we're going to go 9 factorial on the top. Then I'm going to divide it by any letters that repeat. So I can see that those E's right there, they're repeat. And so I'm going to go 2 factorial on the bottom. I have those Y's right there that repeat, so I can go another 2 factorial on the bottom. And then everything else is unique, so when I'm done with that, I can just put that number in on my calculator. I get 90,720 for the unique permutations of the word yesterday. All right, so hopefully you've had time to try this one on your own. This is the word 17. Now when you count the letters to the word 17, I counted 9 letters, so 9 factorial goes on the top. Then I have to take my repeats. I'm going to start with the E's. So 1, 2, 3, 4. So there's 4 repeats on the E. And then I have these ands I need to worry about. So 2 factorial on the ands that repeat. And then it looks like to me that everything else is unique, meaning it doesn't repeat again. So I'm going to punch this on my calculator. And when I get that punched in my calculator and hit equals, my answer is 7,560. All right, so that's how we do the combinations of words and letters. So there'll be a bunch of those on your homework assignment, but let's do a couple of different problems here that are just some combination problems, and we'll remember doing some of these from the other day. So it says here, find the number of ways 6 donuts can be selected from 20 donuts. That's a typo there, but that's supposed to be the word from. So from 20 donuts. Does order matter? If order matters, then it's a permutation. If order does not matter, then it's a combination. Well, it didn't say I had to pick the donuts in a certain order, so I know I'm doing a combination. So I'm taking 20 items, 6 at a time. So I'm going to do the combination of 20 items taken 6 at a time. Again, on that probability key on your calculator, you have that combination key. It's number 2 underneath the probability key. And on your calculator, you're going to hit the number 20. You're going to hit that probability key. Then underneath the probability key, you're going to hit the number 2 because the NCR key is right there. And then you're going to put in the number 6, and that's going to find the combination of 20 items taken 6 at a time. Your calculator will just do that work for you. And when you do that, you get 38,760 different combinations that you can take 6 donuts out of 20. We're going to look at this next example here too and see if it's a combination or a permutation. So it says find the number of ways that 3 math teachers can be selected from a group of 7 math teachers. Well, it didn't seem to me that orders matter because it didn't say that they had special positions or sitting in certain seats or anything. So this is again a combination. We'll always start with the highest number. So there's 7 math teachers that we can choose from. We're taking them in groups of 3 or 3 at a time. So we're doing the combination here. Again, we're punching that in on our calculator using that combination key underneath the probability key. And when you punch that in, you get the number 35 for your solution. Okay, a couple more problems. These ones are what we would call complex combinations because we have to do 2 groups of something in one group. So it says a class consists of 15 boys of whom 5 are prefects. How many committees of 8 can be formed if it consists of exactly 2 prefects? Now I'm not going to lie, I had to look up what a prefect was because I had no idea. It's a slang term from Harry Potter that talks about people who have the students who have the right to kind of patrol and be in charge, kind of like a hall monitor kind of thing. So we're talking about different groups here. So the hints on how to solve this are down below. It says, well, what's the number of ways you can choose 2 prefects out of 5? Well, that would be a combination of 5 people taken 2 at a time. And we can actually find that by just punching that into our calculator. And our calculator is going to give us the answer of the number 10 for that. The second part would be what is the number of ways of choosing 6 non-prefects from a group of 10? And where did the group of 10 come from? Well, there was 15 boys and 5 of them were prefects, which mean that 10 were not. So we're going to do 10 boys taken 6 at a time. When we do that on our calculator, we get 210. Then the last step on this would be to get the possible outcomes of the committee that has exactly 2 prefects. We would multiply those 2 answers together. So 10 times 210, which gives me 2,100. So my answer for that problem would be 2,100. All right, I want you to take a second and see if you can do this one on your own. You can just pause the video right here and see if you can do it on your own, and then just push play again when you're ready to try it out on your own. But this problem says Mrs. Bliss needs to form a group from her first 2 classes. There are 25 students in period 1 and 30 students in period 2. How many committees of 8 can be formed if it consists of exactly 4 from each period? So again, the hints here says, well, what's the number of ways of choosing 4 students from period 1? Well, how many students were in period 1? There's 25. I'm going to choose them 4 at a time. Again, this is a combination because order does not matter here. And I can find that number on my calculator. That number is 12,650 if I punch it in right. Then the second part says, what is the number of ways of choosing 4 students in second period? Well, in second period, there were 30 students. So I'm taking 30 students and I'm going to just choose 4 of them at a time. If I punch that in my calculator, it will tell me the combination of the possibilities of that happening. And that's 27,405. And then we would multiply those 2 answers together to get the combination of that group or committee that we can get 4 from each class. So this number, when you multiply it together, is actually really large. We put our commas back in that. We're at 346,673,250. So this is how we're doing some combinations and permutations today. Thanks for watching and good luck with your assignment.